Hey guys, welcome back. Fred here from AF Math and Engineering. Thanks for tuning in today. This is our second video on our SAP 2000 introductory tutorial section. So these videos are geared towards young engineering students, maybe in the earlier years, or young engineers who are looking to use SAP 2000 as a tool in their engineering studies to help them, verify their homework questions and to help them get 100% in their studies. So that is the purpose of this video, and specifically the purpose of this video is going to be on trusses. Okay, because as we know in civil engineering, we're going to be dealing with a lot of different truss questions. So we're going to show you how to input the truss into SAP, and we're going to show you how to get the output that you desire. So the joint displacements, the member end forces, where those are located in SAP, and that's pretty much it. And once again, guys, before I start, if you're enjoying the video, hit that subscribe button down below. If you're enjoying our channel, really motivates us to continue to make videos. And thanks again for everyone for all the support so far. It's been awesome. So with that being said, let's go ahead and start it up. And as always, the link to the SAP 2000 evaluation version is in the description. Okay, go ahead and apply. If you're a university student, you can definitely get this evaluation version here. There are some limitations, but at the end of the day, that's not really that big of a deal. It works quite fine, just as the evaluation version. So we have a truss here on the right-hand side of the screen, okay? And this is the truss with the loadings. We have 2 point loadings here, 35 kilonewton at D and 84 kilonewton at B. We're given the modulus of elasticity. We're given the cross-sectional area of the members, and that is essentially it. We're also given, the solved truss, okay, with the reactions. We have the forces in the members, and we have the deflection at B. So I'm going to show you how to get all of those things really quickly in SAP 2000. So first we're going to go ahead and we're going to start our new model. So File, New Model. And we're going to go to Grid only. Okay, so we're going to go to Grid this time. Now, if you haven't watched our other video on beams, I highly suggest that you do that because I might kind of go a little quickly through these just to make the video shorter. So go back and check out that video if you haven't done it already. That was like our first video. But we're going to start with our grid lines. Okay, so our grid lines here are going to be, and if you'll remember in the other question, this is our x-plane here always. So when we're looking at it as it's presented to us in the book, the horizontal axis along the page there is x. Okay, up and down here is z, and into the page is y. Okay, so that's the coordinate system in SAP. So for our grid lines here, okay, I'm going to make 2 grid lines. See, in this case, this is a good trick here because there's 4 meters and then 3 meters. So let's first select the number of grid lines. We have 1, 2, 3 grid lines here. And in the z direction, we have 1, 2 grid lines. And in the y direction, we don't have any grid lines. This isn't going into the page. It's like a 2D structure, so we'll just put 1 there. For the grid spacing, this is a little bit of a trick here. I'm going to put 4 for now. Okay, so we're going to have 4 and 4, and then we're just going to edit it right after. Y direction doesn't matter, and for Z direction, we do have 4 meter spacing here, so we're going to want to put 4 meters for that. So press OK, and once again, we have our XY plane and our 3D view. So let's get out of the 3D view and go to the XZ plane because that's how it looks on the page, XZ. And as you can see here, we have 4 meters and 4 meters here, okay, and that's not what we want. So we have, if you take a look at the bottom down here, okay, that'll show you that we have x equals 4 and x equals 8, but we want x equals 7, right, because it's 4 and 3. So just right-click on the screen and click Edit Grid Data, and you're going to see the global system there. Click Modify, and here is our x grid data. Okay, so we have A, B, and C. So we want to change this from 8 to 7. So I'm just going to double-click on that. Okay, I'm going to highlight it, and I'm going to push 7, and then I'm going to go ahead and press Enter to apply that, and press OK. And as you can see, now we have x equals 7 here. So that's what we want. So let's go ahead and start by defining the properties of our members. So we're going to go to the first step always, and we're going to define our materials. So let's go to Define. We're going to hit Materials there, and let's add a new material. Okay, so let's just press OK. This is all fine. And we're going to modify that material that we just added. Let's say this is truss. Okay. Once again, our unit weight is 0, weight per unit volume. Okay, always assumed in these books unless specified specifically for the structural analysis stuff. Okay, modulus elasticity is going to be, we have 200 GPa over here, so 2E08. And like I said before, if you're not sure what it is in those units, you can always do the shift double click, bring the calculator up, and input the GPa in the units that you would like. Okay, so that's good to know. What else do we have here? That's it. That's everything for this page. Let's press OK. Our material is defined. Let's go over to section properties now. Okay, so we're at section properties, and let's go ahead and click frame sections again. And now we're going to add a new property. Okay, and for example, if this is like a steel design course, something like that, and you're given the shape, maybe these are angles, steel angles or something, you can import them using these presets here. But we are just given the area. That's it. That's all we care about here. So in that case, we're going to go to Other and go to General. And we're going to define our cross-sectional area, right? Because these are tensional members and compressional members. There's no bending going on within the truss and the members, so we don't care about the moment of inertia. All we care about is the cross-sectional area. So within the cross-sectional area here, we're going to put our value of 1200 millimeters squared. As you remember, though, we're in kilonewton and meters here. So we do need to go ahead and bring out our calculator. And let's go ahead and put that into millimeter. It doesn't matter what force unit you select. Just make sure you select a millimeter unit here. And we're going to put, we have 1,200. Let me just move that out of the way for you. We have 1,200 millimeters. And SAP, once we press OK, is immediately going to convert that to the units that are specified down here. As you see, we have kilonewton and meters. So we have a meter unit. All right, so that's everything here. Very good. Press OK. And let's rename our section to be truss. And our material, let's select truss, that material that we selected there, and press OK. And finally, we're going to go to define, and we're going to go to our load patterns. And we're just going to make the self-weight multiplier 0. I think that's a good habit to get into. And if you don't know why I did that, go back to the last video. I explained it there. Now that we've done that, that's a good start. We're pretty much ready to go. So we're ready to start drawing our truss. So this, as you can see, as you get fast at this, I mean, this is a great way to check your answers. It doesn't take very long to input these trusses into SAP and really, double check that you're handing in the right thing. So like I said, something I wish I had in second year, but that's why I'm showing you guys. So make sure that you've selected truss for your section, the one that we just defined in our frame sections, and start to draw the truss exactly as you see it here, stopping at every joint. Okay, so we're going to go from point A over to point D, over to point C. Okay, we're going to go to B. I'm going to go over here to D. Not the best way to do it. Right click to end it if you kind of messed up like I did there, and go from A to B. And we've started to draw the truss here. Now let's go ahead and assign our restraints. We have a pin and we have a roller there. So a pin at A. Let's go ahead and assign a joint restraint. Okay, and we have a pin. Select the pin, press OK. Go to C. Okay, assign joint restraints. Select the roller, press OK. And now our restraints and our supports are assigned. Let's go ahead and assign these loads now, these point loads. So as you can see, we have a 35 kilonewton point load at D. It's going in the negative X direction. So we're going to go to assign, and we're going to go to joint loads and forces. And we're going to go to the global X, okay, and we would like to assign a negative 35 kilonewton force. It doesn't matter what option you have because there's no other forces at that point. Okay, so as you can see, we have a 35 kilonewton point load there. Go over to B. We have our negative 84 in the Z plane. Remember, ZX, okay? Assign a joint load there in the Z. Don't reassign that. Make that 0. I don't know why SAP does that. And we have negative 84. Okay, press OK. Very good. Now, you may think that you're done in this case, and then there's no worries. But you have to remember, and this is the key thing to remember here in SAP, is that these are all considered to be rigid joints here. Okay, so they're restrained against rotation. They're fixed joints, and if you were to analyze this like this, you would analyze it as a frame with rigid joints here, and you're going to get something completely different, and you're going to be wondering, what's going on here. So what you do need to do is you need to release all of these joints here against rotation. Yeah, essentially you have to make them pins. And how we're going to do that is we're going to go here and we're going to select our entire structure. Okay, we're going to go to assign. Okay, we're going to go to frame. All right, and we're going to go to release/partial fixity. Double click on that, and what that's going to do is that's going to allow us, okay, to select the start and the end of each member and release them against moment. So essentially we're going to release the restraints against moment here. Okay, and as you can see, we have 0 moment on the ends of all of these, which essentially means that it's pinned on the ends. Okay, and we're going to press OK, and you can see these little green dots come up. Okay, so that means that our end members have been released against rotation. They're allowed to rotate now, so these are all pinned members, and it is now a truss that is pinned. As you remember, trusses are always pinned. And now we can go ahead and we can start to analyze this structure. So we're going to go to Analyze, and we're going to run this analysis. We're not going to run a modal analysis. We're only going to run our dead load analysis, so our linear static analysis. We're going to run now, and let's go ahead and relabel this, rename it whatever. Okay, save it. And as you can see, we now have our deflected shape here of our truss, and we can go ahead and start to analyze. Let's compare what they got here in this question to what we got. So let's go over to this show forces and stresses. Let's take a look at the reactions first. And as you can see, we got a 56, 35, we got 28 up, and that's exactly what they have for the reactions here. Very good. Now, as you can see in this little check mark box, we have set display options. Let's click on that, and let's go label the joints, and let's also label the frame section. Okay, we're going to label the sections here, and we've also labeled the joints. So when we look at, for example, which member is which force in our table, we're going to know which one's which. So let's take a look at these forces in each member, and I'm going to show you how to do that. I'm also going to show you at the same time how to find that deflection. So go ahead, go to Display, and go to Show Tables. Okay, so you're going to go to Show Tables, and you're going to see that this screen comes up. Okay, so we have Choose Tables for Display. And if we go to Analysis Results, we can take a look at, for example, the joint displacements. So you can go ahead and maximize these little boxes here. So we want to take a look at the joint displacements because we want to look at what the displacement is at B to compare. We also want to take a look at the member forces. So let's go to Element Output, and we're going to go to Frame Output, and we want to go to the Element Forces. Okay, so you can select whatever you want. You can look at the stresses, the joint forces. There's a lot of different things that SAP will output for you. But for this one, we just want to look at the element forces, and we want to look at the reactions and the joint displacements. So go ahead and push OK, and what's going to come up is a table here. And this is why we went ahead and we labeled the truss, because now we can take a look at what it corresponds to. So let's go ahead to joint displacements first. And as you can see, if we go over to joint 4 here, okay, just put this here for you. Okay, so if we go over to joint 4, which is B on the truss, they got for the horizontal displacement 0.35 to the right millimeter and 3.32 millimeter down. And as you can see, if we go to joint 4 U1, okay, which is the 1 axis, so that is the X direction, okay, that is 0.35 so millimeter. That is correct here, and this is in meters, so but that is correct. That's the right direction. And then we have negative 0.332, or they actually have more decimals here, 0.3315 down displacement at joint 4, which is joint B in our question. So there, that's exactly correct, exactly the same thing that they got here. Let's go ahead and take a look at the element forces. And as you'll see, so frame member 1, we have a compression of 79.196, 79.2, they rounded it here, and 35 compression for, yes, okay, so that's all good. So we have 79.2, 79.2, 35, 35, okay, we have 21 here, that is member 3, 21, okay, cool. So, and the directions are included. We have negatives and positives corresponding to compression and tension. And there you go. That's pretty much it. So these tables can be exported, not actually in the evaluation version. You need the full version to export them to Excel. But this is a great way, like I said, if you have that really important assignment that you're going to need to go ahead and check, make sure that all of your forces and your displacements are correct before you hand it in. This is a great way. Just throw it in SAP. Once you get good at it, it'll take about 5 minutes or so. And you can really benefit from this in your engineering studies, especially in second year when you're doing all those statics courses. So I hope you learned something from this. I hope you learned how to input a truss into SAP 2000 and how to get the outputs that you so desire. And like I said, as always, if you enjoyed the video, hit that like button, hit that subscribe button. I'm Fred from the AF Math Engineering, and thanks for watching.